Databricks machine learning. Imagine you're building a robot that can predict the weather. You need to feed it lots of data about past weather patterns, temperature, humidity, wind speed, etc. Databricks machine learning is like a super smart workshop where you can build and train your robot and keep track of everything you do. Here's how it works. 1. Data management. Data versioning. Think of it like taking snapshots of your data. You can always go back and see what your data looked like at a certain point in time. This helps you make sure your robot is learning from consistent information. Data lineage. This helps you understand the journey of your data. Imagine a map showing how your data moves from one step to the next, so you can see if anything is getting lost or changed in a way you didn't intend. 2. Model development. Version control. It's like keeping a log of all the changes you make to your robot's brain. This helps you track how you've improved it over time and easily go back to earlier versions if needed. Experiment tracking. It's like a journal where you record all the experiments you do with your robot. You can see how well it performs with different settings, like how much data you feed it, and find the best configuration. 3. Model deployment and monitoring. Automated deployment. This is like having a conveyor belt that smoothly moves your trained robot from the workshop to its real-world job of predicting the weather. You don't have to do all the manual work of setting it up. Real-time monitoring. It's like having a camera on your robot that constantly watches how it's performing in the real world. If it starts making mistakes or getting confused, you can quickly jump in and fix it. Example. Let's say you're building a robot to predict traffic jams. You feed it data on past traffic patterns, road closures, and weather conditions. Data versioning. You take a snapshot of your data every time you get new information about road closures. This way, you know exactly which data was used to train your robot at a certain point. Data lineage. You can see a map of how your data is combined and processed to make sure you're using the right information for your predictions. Version control. You keep track of all the changes you make to your robot's algorithm. This helps you compare different versions and see which one works best. Experiment tracking. You run experiments to see how your robot performs with different types of data, like only using traffic camera footage or including weather data. Automated deployment. You automatically deploy your robot to a website that gives people real-time traffic predictions. Real-time monitoring. You monitor the robot's performance and see if it's getting confused by any new situations, like a major event that causes unexpected traffic. Databricks machine learning makes it easy to build, test, and deploy robots or machine learning models that can solve all kinds of problems, from predicting the weather to helping you find the best deals online.
MLOps best practices. Imagine you're baking a cake. You have a recipe, but you want to make sure it always turns out perfect. That's where MLOps best practices come in. They help you build, deploy, and monitor your machine learning models like a pro. Think of MLOps as a set of guidelines to make sure your machine learning projects are well organized and reliable. Just like following a recipe, these practices make your model building process smoother and more successful. Here are some of the key MLOps best practices. Data management, data versioning. Remember when you accidentally added too much sugar to your cake? Data versioning is like keeping a record of all the ingredients you used. If something goes wrong, you can always go back to a previous version and try again. This makes sure your models are always using the right data. Data lineage. Imagine following the journey of a single flour particle in your cake batter. Data lineage helps you track the path of your data from its origin to the final model. This helps you understand where problems might arise and fix them quickly. Model development. Version control. Similar to keeping track of your cake recipe, version control helps you track changes in your model code and configurations. If your model starts acting strangely, you can see exactly what changes were made and find the cause of the problem. Experiment tracking. Imagine trying different amounts of sugar in your cake. Experiment tracking helps you keep track of all the different ways you've trained your model and their results. This lets you compare and choose the best performing model for your needs. Model deployment and monitoring. Automated deployment. Imagine having a robot that automatically bakes your cake after you've finalized the recipe. Automated deployment helps you quickly and efficiently move your trained model to different environments like testing and production. This saves you time and makes your models available for use much faster. Real-time monitoring. Once your cake is baked, you want to make sure it stays fresh and doesn't get burnt. Real-time monitoring helps you keep an eye on your model's performance in the real world. This lets you detect any issues early and adjust your model or fix any problems before they become bigger. By following these MLOps best practices, you can create a strong foundation for your machine learning projects and ensure your models are reliable and perform well.
Data management. Data management. Keeping your data organized and reliable. Imagine you're building a house. You wouldn't just start throwing bricks and wood everywhere, right? You need a plan, a system to keep things organized and make sure everything fits together. Data management is like the blueprint for your machine learning project. It helps you keep your data organized, reliable, and easy to work with. Here's how data management works in machine learning. 1. Data versioning. Tracking changes like a time machine. Just like your phone takes pictures and videos, data versioning lets you capture snapshots of your data at different points in time. This is super helpful because it lets you go back in time. If you realize your model isn't performing well, you can go back to an earlier version of your data and see if that fixes the problem. Know what changed. You can compare different versions of your data to understand exactly what was modified. Example: imagine you're training a model to predict house prices. You might have data from 2020, 2021, and 2022. If you discover your model is off in 2022, data versioning helps you quickly compare the 2022 data to the older versions to see if there's a big change in house prices or other factors that might be causing the issue. 2. Data lineage. Tracing your data's journey. Think of data lineage like a map showing how your data flows through your machine learning project. It helps you track where your data came from, how it was processed, and what changes were made along the way. This is like following a package from the factory to your doorstep. Why is data lineage important? Finding errors. If your model is giving wrong answers, data lineage helps you trace the problem back to its source. Maybe there was a mistake in how the data was cleaned or transformed. Understanding your data. It helps you understand the entire process and see how changes in your data affect the final output. Example: imagine you're training a model to predict customer spending. Data lineage would show you how raw data from your website was cleaned, transformed, and prepared before being fed to your model. If you find an error in your model's predictions, data lineage helps you quickly trace the error back to a specific step in the process. In short, data management is all about making sure your data is organized, reliable, and easy to understand. It's like having a well-organized toolbox, so you can build your machine learning models with confidence.
Data versioning. Imagine you're building a house. You wouldn't just randomly start putting bricks together, right? You'd have blueprints, plans, and a clear understanding of how each piece fits into the whole structure. Data versioning is like having those blueprints for your data. It's a way to keep track of changes made to your data over time, so you can always go back to a previous version if needed. Think of it like this: version 1. You start with a basic dataset about customer purchases. This is like the initial foundation of your house. Version 2. You add new information about customer demographics, like age and location. This is like adding more rooms to your house. Version 3. You accidentally delete some data, but no worries, you can go back to version 2, which had all the information you need. Why is data versioning important? Reproducibility. If you make changes to your data and your model's performance drops, you can easily go back to a previous version to see what went wrong. Collaboration. When working with others, everyone can access the same version of the data, avoiding confusion and wasted time. Trust. Knowing that you can always go back to a previous version of your data gives you confidence in your analysis and model results. Data versioning helps you manage your data like a well-organized construction project, ensuring everything is in its place, and you can always go back to a previous state if needed.
Data lineage. Imagine you're making a delicious cake. You start with flour, sugar, eggs, and milk. You mix them together, bake them, and then add frosting. Each ingredient and step is a part of the cake's journey, right? Data lineage is like tracing the journey of your data in a machine learning project. It's about understanding where your data comes from, how it's transformed, and what happens to it along the way. Think of it like this: data source. The flour, sugar, eggs, and milk are your raw data. They might come from different sources like databases, files, or even online platforms. Data transformations. The mixing, baking, and frosting are like the changes you make to your data. This could include cleaning messy data, combining different datasets, or applying mathematical formulas. Model training. The final cake is your machine learning model, trained using the transformed data. Model deployment. Serving the cake is like using the model to make predictions in the real world. Why is data lineage important? Troubleshooting. If your cake doesn't turn out right, you can trace back the steps to find the problem. Similarly, if your machine learning model isn't performing well, data lineage helps you pinpoint where things might have gone wrong. Reproducibility. Imagine trying to recreate the cake recipe without knowing the ingredients or the steps. Data lineage ensures you can recreate your machine learning project by tracking all the data transformations in code. Data quality. Knowing the data's journey helps you understand its quality and potential biases. You can identify if there are any issues that need to be addressed. Example. Let's say you're building a model to predict customer churn, whether a customer will leave your service. Your data comes from different sources: customer demographics, purchase history, and website activity. Data lineage helps you understand where the data comes from, each source, how the data is combined and cleaned, transformations. What features are used to train the model? This way, if your churn prediction model isn't accurate, you can trace back to see if there are any issues with the data, the transformations, or even the model itself.
Model development. Model development, building the brains of your machine learning project. Think of model development as the heart of your machine learning project. This is where you actually create the brain of your model, the part that learns from data and makes predictions. Here's how it works. 1. Version control. Imagine you're building a house. You wouldn't just start adding bricks without a plan, right? Version control and model development is like your blueprint. It helps you keep track of all the changes you make to your model's code, configurations, and dependencies. This is super important because traceability. If you have a problem, you can easily go back and see what changes you made that might have caused it. Collaboration. If you're working with a team, everyone can see who made which changes and what the results were. Example. Let's say you're building a model to predict house prices. You might start with a simple model, but then decide to add more features, like the size of the garden, or try different algorithms. Version control helps you track all these changes and makes sure everyone is on the same page. 2. Experiment tracking. Now imagine you have several different blueprints for your house, each with slightly different designs. Experiment tracking is like comparing these blueprints to see which one will create the best house. It lets you monitor model performance. You can track how well your model is performing on different datasets, like training data and testing data, to see if it's improving or getting worse. Tune hyperparameters. Every model has some settings that can be adjusted, like how much it learns from each data point. Experiment tracking helps you find the best combination of settings to optimize your model's performance. Analyze training metrics. It gives you insights into how your model is learning, like how fast it's converging on a solution. Example. In our house price prediction example, you might try different algorithms, like a linear regression model or a decision tree. You'd use experiment tracking to see which algorithm performs best with your data. You might also experiment with different parameters within each algorithm to see what gives you the most accurate results. In short, version control and experiment tracking are essential for building reliable and efficient machine learning models. They help you make sure your models are well documented, can be improved over time, and are built on a solid foundation.
Version control. Imagine you're building a house. You start with a blueprint, and as you build, you make changes. Maybe you add a window or change the size of a room. To keep track of all these changes, you'd probably create different versions of the blueprint, right? Version control in machine learning is like that blueprint. It helps you track all the changes you make to your machine learning models. It's like a time machine for your code. Here's how it works. 1. Saving your work. You start with a basic model, like your initial blueprint. You then make changes to it, like adding a window or changing a room's size. Version control allows you to save each of these changes as a separate version. This way, you have a record of every step you took in building your model. 2. Keeping track. Let's say you make 10 changes to your model. Version control keeps track of all 10 versions, allowing you to easily see what changed between each one. This makes it much easier to understand how your model evolved and why it's performing the way it does. 3. Rolling back changes. Sometimes you might make a change to your model and realize it wasn't a good idea. With version control, you can easily roll back to a previous version of your model, undoing the bad change. It's like saying, "Oops, I want the house to be like it was before I added that window." 4. Collaborating with others. Version control is also great for teamwork. Imagine you're working with a team on a machine learning project. Everyone can make changes to the model, and version control ensures everyone is working on the same version. preventing confusion and messy code. Think of it like this: version control is your notebook for your machine learning model. Each version is like a new page in your notebook, recording every change you make. You can flip through the pages to see how your model has evolved. Version control is an essential tool for anyone working with machine learning, making it much easier to manage your work, track progress, and collaborate with others.
Experiment tracking. Imagine you're baking a cake. You try different recipes, maybe adding more sugar or less flour to see what makes the best cake. Experiment tracking is like keeping a detailed diary of all your baking attempts. In machine learning, we're trying to build the best possible model. Just like finding the perfect cake recipe, experiment tracking helps us keep track of all the changes we make to our model, like the type of ingredients, data, the oven temperature, hyperparameters, and the baking time, training time. Here's how it works. 1. Keeping track of everything. When you start training a model, you might try different things like changing the data, using a different set of information to train the model, adjusting the settings, tweaking the model's parameters like the learning rate or the number of layers, trying different algorithms, using a different type of model altogether. 2. Recording the results. For each experiment, you record the changes you made, what data did you use, what settings did you change, how the model performed, did it make accurate predictions, how long did it take to train? 3. Learning from past experiments. By looking at all the experiments you've done, you can see what worked best, which combinations of data, settings, and algorithms gave the best results, what didn't work, which changes made the model perform worse. Example. Let's say you're building a model to predict house prices. You try 2 different experiments. Experiment 1. Data. Use all the data you have, including house size, location, and age. Settings. Use a basic model with default settings. Performance. The model predicts prices fairly well, but not perfectly. Experiment 2. Data. Use only data for houses in a specific city. Settings. Try a more complex model with extra layers. Performance. The model is very accurate at predicting prices for houses in that city, but not for houses outside of it. By tracking these experiments, you can see that focusing on specific data, houses in a city, and using a more complex model can improve performance. Why is experiment tracking important? It helps you learn faster. You can see what worked and what didn't, so you can make better decisions about future experiments. It saves time. You don't have to repeat experiments you've already done. It makes your work reproducible. Anyone can see how you got your results, so you can share your work with others. Just like a good recipe, a well-tracked machine learning experiment helps you create the best possible model.
Model deployment and monitoring. Model deployment and monitoring. Making your model work in the real world. Imagine you've built a fantastic machine learning model. It predicts customer behavior, identifies patterns in images, or maybe even writes poetry. Now, you want to use it. That's where model deployment and monitoring comes in. 1. Automated deployment. Making your model go live easily. Deployment is like moving your model from the lab to the real world. It's about making your model accessible to other systems or users. Think of it like this. You have a delicious recipe, but it's only useful if you actually cook it. Automated deployment helps you cook your model, making it work in real-time scenarios. How it works. Instead of manually copying and pasting code, you use tools to automatically deploy your model to different environments. These tools handle things like setting up the necessary infrastructure, ensuring all the required software is installed, and making sure your model connects to the right data sources. Example. Imagine your model predicts the best time to send marketing emails. You can set up automated deployment to send your model to a system that automatically triggers email campaigns. 2. Real-time monitoring. Keeping an eye on your model's performance after deployment, you need to make sure your model is still doing its job. That's where monitoring comes in. Think of it like this. You have a car. After driving it, you check the fuel gauge, tire pressure, and engine temperature to make sure everything is running smoothly. How it works. Monitoring tools track your model's performance in real time. They check things like, how accurate is it still? Are there any errors happening? Is it responding quickly enough? Example. If your model predicts customer churn, you can monitor it to see if it's accurately predicting which customers are likely to leave. If you notice a decline in accuracy, it might mean you need to update your model with new data or fine-tune its settings. Why are these important? Reliability. Monitoring helps you catch problems quickly, ensuring your model remains reliable and delivers accurate results. Continuous improvement. Monitoring helps you understand how your model is performing, giving you valuable insights for improving it over time. Efficiency. Automated deployment saves you time and effort, allowing you to focus on more strategic tasks. In simple terms, model deployment and monitoring ensures your machine learning model is working correctly and delivers real value.
Automated deployment. Imagine you've built a fantastic new machine learning model. It's like a super smart robot that can predict things based on data. Now you want to make this robot work in the real world, helping your company make better decisions. This is where automated deployment comes in. It's like a magical conveyor belt that takes your model from your computer, where you built it, and smoothly delivers it to a special server where it can be used by everyone. Here's how it works. 1. You build your model. You've done all the hard work, training your model on data and making it super smart. 2. The conveyor belt starts. Automated deployment takes your model and all its instructions, like how to use the data, and packages them neatly. It's like putting all the pieces of a puzzle in a box. 3. The box is shipped. This package is sent to a special server in the cloud, ready to be used. 4. The robot gets to work. The server uses the instructions in the package to make your model available to everyone. It's like your robot is now ready to work in the real world. Example. Let's say your model can predict how many customers will visit a store each day. With automated deployment, you can easily put it on a server that your store uses. Then, every day, the server can tell the store how many people they should expect, helping them prepare and make better decisions about staffing and inventory. Benefits of automated deployment. Speed. No more manually copying and pasting code. Automated deployment makes it super fast to get your model working. Reliability. It ensures that your model works perfectly every time. Less errors. It reduces the chance of mistakes when you're putting your model into use. Scalability. It allows you to easily deploy your model to many different servers, letting it work for more people. Automated deployment is like a superhero for machine learning. It makes it easy to share your smart robots with the world, helping everyone make better decisions.
Real-time monitoring. Imagine you've built a super smart machine learning model that can predict the weather. You've put it into action, and it's now forecasting the weather for everyone to see. But how do you know if your model is still working correctly? This is where real-time monitoring comes in. Think of real-time monitoring as having a watchful eye on your model while it's doing its job in the real world. It's like having a team of scientists constantly checking the model's predictions against the actual weather. Here's how real-time monitoring works. Data drift detection. The weather changes all the time, right? Maybe a new weather pattern emerges or a change in climate occurs. Real-time monitoring helps you see if the data your model is using to make predictions is changing in ways that could make it inaccurate. It's like noticing that your model is suddenly making lots of incorrect predictions about sunshine when it should be predicting rain. Performance monitoring. Just like you might check your car's fuel gauge, real-time monitoring checks how well your model is performing. It looks at things like how accurate its predictions are and how fast it can make them. If the model's performance starts to dip, it's like your car running out of gas. You need to figure out what's wrong and fix it. Alerting. When real-time monitoring detects a problem, it sends you an alert. Imagine it's like a red warning light on your dashboard. It tells you that your model needs attention. Maybe it's time to update the model with new data or make adjustments to its settings. Here's an example. Let's say you built a model that predicts the price of a certain type of fruit based on factors like season, weather, and demand. Real-time monitoring could track the model's predictions against the actual fruit prices in the market. If the model starts making significantly wrong predictions, real-time monitoring will alert you. This means you can investigate why the model is struggling and make changes to improve its accuracy. Maybe a new type of fruit has been introduced, or there's a sudden change in the market demand. In a nutshell, real-time monitoring helps you keep your machine learning models healthy and performing well in the real world. It's like giving your model a regular checkup to make sure it's running smoothly and making accurate predictions.